example 5, you're going to notice several things that are different from the opening examples. Number 1, it doesn't officially tell you to do all the hoopla of things of writing the equation in standard form, state the direction, etc. It tells you to sketch a graph, and then there's our answer box, so we'll go ahead and fill that in with the appropriate information. So as we do this, what I want to remind you of is that for a parabola, whenever we are doing a parabola, we're always going to use the name, okay? But then we're going to jump down here and do vertex, focus, directrix, and focal chord. So the nice thing about this box, if you haven't noticed the answer box, it has continued to expand as we go. And what we've noticed is that center and radius are used for a circle. Center, vertices, co-vertices, and foci are used for an ellipse. This was the second one we learned. Then we started to do center, vertices, foci, and asymptote for our hyperbolas. And now we're coming straight down to the bottom for vertex, focus, directrix, and focal chord, because those are the ones that go with a parabola. Now, as I get ready to sketch my graph, we want to pay attention to whether the x squared or the y is squared. So again, if we need to, off to the side, we can always write our little reminder about what this graph could look like. So since this is an x squared and our y is being squared, then I'm going to notice that it's not going to be vertical, which means I could come straight away to saying that it is going to be a horizontal parabola. Now the next thing I want to do is pay attention to whether or not this coefficient is on the squared term. And I notice that the coefficient is in front of the squared term, which is good. And so that's going to tell me, since it's positive, that this is going to open to the right. Okay? Now, traditionally the movement has been missing from the previous example so far. But if we connect it to the other conic shapes that we've seen, or any of the shifts that we've been doing since August, hopefully you're going to think that this is a shift left 5 and up 3, which is correct, and that represents our vertex. Okay? To get the focus and directrix, we want to make sure that we figure out what the value of P is. So I'm going to always encourage you to show that work. So 1 over 4p is our traditional starting spot. That's going to equal 1 over 4, because that's our coefficient on the squared term, which is going to allow us to get a p-value of 1. Now that p-value of 1 tells us how far we move. So I'm going to focus on the graphing option for this. And I'm going to remind you that when you draw your axes do not necessarily have to be drawn in the center. And so I'm going to remind you that you have some options for where you draw those axes. Now right now I'm just drawing them in a different place to remind you of that fact. It has nothing to do necessarily with the numbers in this problem. So I'm going to count 5 to the left and 3 up, and I'm going to put that as my vertex. Now I'm not going to draw the sketch yet, because where I put those other points is going to be dictated by the focal chord, the focus, and the directrix. So I'm not ready to graph those yet. But what I can do is I can count 1 to the right. The reason I'm going to count to the right is because we decided it would open to the right, and the reason it's the value of 1 has to do with the distance of P. Right? P is the distance between vertex and focus. So I'm going to count 1 to the right, so maybe label that with a V, label that with a little F, okay? I'm going to count the opposite direction, and I'm going to put my directrix. And that's a dashed line. So now, before I can finish the sketch, I need to know the length of the focal chord. Now the length of the focal chord is always going to equal 4p. And so if p is 1, the focal chord will be 4 times 1. So in this case will be 4. Now that focal chord, you want to remember, spans the focus. So it's the whole distance across. It's not counting 4 in each direction. It's the total distance. So that means you're going to go 2 up and 2 down from the focus so that the whole focal chord length is 4. And then from there you're going to sketch through those 3 points, the 2 endpoints of the focal chord and our vertex to create your parabola. So we're almost done. We just need to mark and indicate where the focus is. The focus is an ordered pair, so you want to count that it's at -4, +3. And your directrix is over here 1, 2, 3, 4, 5, 6. And so remember, since it's a vertical line, it's x equals -6. And now problem 5 is complete.